circular single linked list. Sir, what is mean by this circular single linked list? Very simple. Here the nodes are attached in a circular manner. Means if you take first node here, one, its next field is nothing but this one. So its next field is nothing but this one. So its next field is nothing but this one. What about this next field? It is attaching to the beginning. That is nothing but what we have. Sir, it is more confusing. Yes, that's why I am covering only limited program. I mean, limited operations I am going to cover on this. Rest of the things you can think and you can implement. Sir, how you can able to point out head node and tail node? Just I will concentrate only on tail. That is nothing but I will concentrate on this tail last node. So if I want to get a head node, what is the head node? Tail tends to next will become head node or not. Like this I am going to maintain. And here compulsory you have to depend on always size. Okay. So this size tail, by using these two pointers only, we are going to run the entire show. So directly I'm taking the program so that you people can understand. Okay. So which program I'm going to take? 1 second. Yeah. So here in 7 p.m. So we have double linked list. So here I'm going to create a new class with the name. So circular single linked list. CSL, circular single linked list. Like this I'm creating. Okay. Now see how I am going to implement. Sir, what are the requirements? We need node tail. Just now I explained, right? Node tail. And integer, what will be the size? Size will become 0. So your size will become 0. 0 elements are there. Then I need to take that node or not? Yes, compulsory. You have to take a child class for node I am taking. And in these, what fields we need to take? As usual, we have data field, which is nothing but a value, and we are going to maintain next field, which is pointing to the next node. And I am going to create a constructor with a value field and a node next field. So this dot value will become value, and this dot next field will become next. Like this I am going to assign. So constructor is okay, class node is okay. So my single linked list structure skeleton template is ready for us. Now you can create a direct object for circular single linked list is equal to list is equal to, so new circular single linked list. Like this I am creating. Sir, what are the operations that we are going to perform? So first operation is nothing but something like print or traverse. I need to print the elements, right? That is nothing but my main requirement. So first I am going to take void print. Sir, what is this operation? By mistake, if your size is equal to 0, then what is the meaning? We don't have any elements, right? Then circular single linked list is empty. We don't have any elements and simply written. Otherwise, node, listen carefully. So we are taking temp is equal to, generally temp is equal to which node we are taking? Head node, right? But I told, right, how can I able to point out a head node? Tail tends to next, while temp is equal to tail tends to next. So until your temp is not equal to, don't take null, because it is a circular fashion. It keep on running. So how you can able to take? Until your temp is not equal to, so tail, until your temp is not equal to tail, then system dot out dot println of. So you have to print a temp dot value, so followed by that link I am going to take. That's all right. And a temp will become temp dot next. Sir, finally we need to print one value. So why we need to print that value, I will explain. Temp dot value we have to print at the end. Okay. 1 second. Now, sir, I will take one example for you to understand. Listen carefully. Suppose consider I have uh, a single circular linked list is there. This is nothing but the first node. Okay. And this is nothing but the second node. Okay. And this is nothing but the third node. And this one is nothing but a fourth. Like this, I have how many nodes are there, sir? Four nodes are there. We know its next field is this one. Its next field is this one. Its next field is this one. Unfortunately, its next field is also this one. And we have a pointer towards this node, which is nothing but a tail. And consider the data, any data you can take. Now, sir, what I am doing is size is equal to 0? No. Okay. Then temp is equal to tail dot next. Tail next field is what? This one, right? I am taking this one as a temp node. Okay. Now, see, listen carefully. Is a temp is not equal to tail? Yes, it is not equal to tail. Then system dot out dot println of temp tends to value 1. Then temp will become temp tends to next. Now onwards, a temp will become this one. Is it not equal to tail? Yes, print the value. Next, your temp will become temp tends to next. Is it not equal to tail? Yes. Then it will become 3. Then your temp will become this one. Sir, is it not equal to tail? No, it is equal to tail. It will come to from this. Finally, we are printing temp tends to value. That's all. Don't print null after this, because anyway it is pointing to the beginning. Okay, anyway it is pointing to the beginning. That's why just I'm not going to print that. Okay, so I hope how to use this print function for a circular single linked list, it is very clear for you. Right, friends? Please confirm if you are okay with this. I will go with addition of elements. If you are okay with this, I will go with addition of elements. Is it clear, friends? Please confirm everyone. Okay, right. Now, anyway, I can't execute, right? Because we don't have these many elements. But if you want to just let me run up to this, I'm trying to print anyway, initially we don't have any elements. The output what we are getting is circular single linked list is empty. Boss, can I add the elements? Yes. I will explain the addition in both places. What is the first one? Add head I'm taking. Okay, add head means what? Inserting at first. Here, first, last, you can't give guarantee because it is in a circular fashion. That's why I will represent add head. Add head means first node. So integer, I am taking value. This value we have to add. Listen carefully. Node temp is equal to, I am creating a new node with this particular value, and the next field is null. Like this I created. Suppose if your size is equal to 0. If size is equal to 0 means what? We don't have any elements. Then your tail will become temp. Okay, your tail will become temp. And then temp dot next will become which one? Temp only. Suppose if already some are there, then what we have to do? So your temp dot next will become tail dot next. Okay, so your temp dot next will become tail dot next, and the tail dot next will become temp. That's all. Very simple operation. And after doing this, what we have to do? Anyway, whether you have executed if or else, immediately size plus plus. First, I will explain how you can able to add at head. Okay, listen carefully. Consider initially we don't have any elements. I want to insert a triple one as a head. Sir, is it otherwise? Let me take triple. Is it available? No. A new node will be created. Okay. So a new node will be created. Since size is equal to 0, your tail will become this node. Actually, the name of this node is nothing but a temp. And this one will become what, sir? Tail node. This one will become what? A tail node. What is its value? It is nothing but a 344. And what about the next field? It is pointing to the same temp. That means this node only. Like this we have. So when you are inserting very first, sir, already one node is there. Suppose consider now already this 344 is there with us. Okay. Now, so consider this is nothing but the link what I have, and this one will become which node, sir? Tail node. Now what we have to do? Add first, right? That's add head, right? That's why here we are going to get a new node. Let us consider the content is nothing but 333. And what is the name of this node? It will become temp, right? Sir, is size is equal to 0? No, one node is there. Then temp tends to next will become tail tends to next. What is the tail tends to next? Unfortunately, it is tail only. Now we are deleting this, and we are making temp tends to next will become tail tends to next. Then tail tends to next will become temp. That's all right. Very simple operation. Suppose consider I want to insert one more item. Already we have two nodes are there. This is nothing but a 344 we have. Okay. And this will become your tail node. So, and we have one more node is there with name 333. So, this link is pointing to this one, and this link is pointing to this one. So here I need to create a new node. Let us consider its data is 311. So this is null initially. And what is its name, sir? It is the temporary. Sir, is the size is equal to 0? No. Temp tends to next. Sir, temp tends to next. We are changing this temp tends to next to. Sir, which one? Tail tends to next. What is the tail one? This one. Its next field is nothing but this one, right? So this node, I am pointing this node. So its next field will become this. So that by default, this one is gone. Now, so tail tends to next will become temp. Like this we are going to say. See here, our main concept is we are fixing that tail pointer. By using that only we are doing almost all the operations. Okay, I think how to add the element at the beginning is clear, but I need to execute, right, to get proof. So first, which one we have added? So add head of, let me add 3. Then list dot add head of, I have added 3. So after that, list dot add head of, so we have added 1. So my expected output is 111 followed by 333 followed by 444. I am expecting. Let us run the code. Is it working? Yes, 111, 333, 444. Sir, there is a small issue. I think at the printing I have used LN. That is the problem here. Okay, otherwise it is going to get it in a single line. Anyway, null won't be there because we should not keep. Why? Because this 444 next field is nothing but a 111. Okay, that's why I am not going to change. So I think this concept is clear for you. Can you please confirm how to add at the node? Is it clear for everyone? Please confirm. Is it clear for everyone? Circular single linked list, add first. Sorry, add head method. Is it clear? Clear? Please confirm everyone. Right. Now I need to talk about so void add tail. At the end, I need to add. Okay, how you are going to add at the ending? Sir, it is also something like same operation, but a bit tricky code we need to write. So node, I'm creating a temporary node with, so the data whatever you have given, and then next field is anyway null. Suppose if your size is equal to 0, if you don't have any elements, then as usual your tail will become that temp node, and your temp dot next. Okay, your temp dot next will become temp only. Sir, I have already certain content is there. Then, so temp tends to next. Your new field next will become tail tends to next. Tail tends to next. That means first node. Then your tail tends to next will become temp and your tail will become temp. That's all. Anyway, after doing this, we have to increment the size. Now I will execute this code. First, I will explain with the help of a small diagram. Observe carefully. Suppose consider I have already some content is there. Like let us take this is 111 and the next field is pointing to 222. Okay. So next field is pointing to 333. Okay. Like this I have. So next node is nothing but okay. Let it be 444 also we will take. Like this we have. And the next field is nothing but this one. What is the name of this one? We know very well it will become tail. Now, sir, I'm creating a new node here. I'm creating a new node here. What is the name of this node? This node will become temporary node. Next field is null and the data is nothing but 555. Like this we have. 1 second. Now, so here is size is equal to 0? No. Else, so temp tends to next will become tail tends to next. Sir, temp tends to next is null, right? Now it will become what? Tail tends to next. Tail tends to next is nothing but 111. So temp tends to next will become what? Tail tends to next. Now, okay. Tail tends to next will become temp. This is the tail, right? Its next field is belongs to temp. Then your tail will become temp. So this will become tail only. So by default, this one is going to be gone. And which links will be deleted? This link will be gone. Okay, like this we have. So, but I need to execute this code, right? To check whether really it is working or not, we need to execute. So already some nodes are there. So I will add list dot. So add tail of. I will take so 555 and list dot add tail of. I need to take a 999. So where the items are going to be added, here it will add 555 and here it is going to add 999. If you execute the output, what we are getting is like this. Okay, sir, clear up to this? Can you please confirm? Is the adding of objects, adding at ending, is it clear for everyone? Please confirm. Clear? Right. Now I need to go for the next one. Okay, I need to go for next one. Can I add at a specific position? Yes. Happily, we can able to add at a position also. So add POS. Here we are going to give the value as well as the position. First I will give position and then later I will give value because that is the correct format, right? Now we need to implement. Sir, how we are going to implement anyway? The creation previously size plus plus. Oh, right. So node temp will become so new node of we are going to take the value and your next field will become null. Suppose if your size is equal to 0. So what will happen? That is our main concept. Otherwise, what we are going to do anyway size plus plus. This is the template, right? If a size is equal to 0, your tail will become so new node. Okay, new node or temp, anything we can take. So better every time we are using new node only, right? Let me habituate. So tail node will become new node. Okay, then your new node tends to next field will become new node only, like this. Suppose if you have elements already, okay, if you have elements already, then if position is equal to 0, that means I want to insert at 0th position, then node temp is equal to, so tail dot next, tail dot next. Okay, so tail dot next, that means it will comes under beginning, then your new node is there, right? Your new node next field will become temp. Okay, so your tail tends to next will become new node. Don't worry, I will explain this code. Like this we have. So then immediately I need to come out from this, I will use return. So if position is not equal to 0, what we are doing? I need some temporary node which will always pointing to tail dot next, and I need to identify the position, right? That's why I is equal to 0. So while your temp dot next is not equal to tail, at the same time I less than position minus 1, then I am moving temp is equal to temp dot next, and as usual I plus plus. So if this while loop fails, then what is the meaning? We came to the perfect position. Then new node dot next will become, so temp dot next, and temp dot next will become, okay, new node. That's all. This is the code what we have. Anyway, I will write and I will explain. Listen carefully. Suppose two cases are there. What is the first case here is, this is nothing but the node I have. This is nothing but the nodes I have. Okay. Consider this one is 1, 2, 3. Next field is nothing but this one. Next field is nothing but this one. This next field we know very well. It is this one. And this one will become tail. Now I want to insert the node called 9 in 0th position. So how you can able to insert at 0th position? Very simple. So we have to create a new node here. Okay, we have to create a new node here. This will become new. Now temp is equal to tail dot next. Tail dot next will become temp. This is nothing but a temp. Then observe carefully. I am breaking the links. Temp will become tail tends to next. New node tends to next will become temp. New node tends to next will become temp. Okay, tail tends to next will become new node. Tail tends to, so next will become your new node. Okay, so like this I am going to break, so that what will happen? By default this link is gone, right? This is nothing but one way what we have. Suppose if I have elements already, something like 1 I have. Okay, so next and after that 2 I have. So next and after that 4 I have. So I need to add 9 here. Okay, I need to add 9 here. This one will become new node, and this one is nothing but a tail node, and next field is nothing but this one. Its next field is nothing but this one. Its next field is nothing but this one. Okay, your temp will become tail tends to next. Tail tends to next. This is nothing but my, so temp node. I is equal to 0. Sir, which position you need to insert? Your position will become 0, 1, 2 in second position. So temp tends to next is not equal to null. Temp tends to next is not equal to tail. Okay, and I less than position, 0 less than, so 2 minus 1 means 1 condition. Then your temp will become temp tends to next. Then I plus plus, your I value will become 1, and the temp tends to next is not equal to tail. Oh, here temp tends to next is equal to tail. Suppose consider we have another node is there, so that you people get that. So I have another is there, like this. Now, sir, temp tends to next is not equal to tail. Yes, temp tends to next is not equal to tail, but I less than position, 1 less than 1 condition is not satisfied. So means here we have to insert that. Now what will happen? Your temp will become, sorry, it is going to fail. New node tends to next will become temp tends to next. So new node tends to next will become temp tends to next. Now observe carefully. New node tends to next will become temp tends to next. That is this one. And temp tends to next will become new node. Temp tends to next will become new node. Like we are going to break this link. That's all right. I will execute this code up to this so that we can cross check whether it is working properly or not. Okay. Second, another batch is there. Just I will give the message. Right. So I will add tail. So I'm going to use add tail method. First one, and then two, and then three, and then four. Like this I have. So what elements are there? So I have one followed by two, so followed by three, so followed by four. Like this I have. Really, is it happening or not? Yes, 1 2 3 4. Like this I have. Excellent. Now, sir, I need to add at a position. So list dot add position of in 0th position. I want to add 9. So where 9 is going to be added here, right? Let me cross check. Is it added or not? Yes. I want to add at a first position. That means 9 we are going to get here. Is it correct? Perfect. Sir, I want to add at a 2. That means where we have to get 9. So here we have to get 9. Is it correct? Perfect. Sir, I want to add at third position. Where it has to be added here. Let me cross check. Perfect. Sir, I want to add at fourth position. Okay. Let us cross check. I think it is not going to be affected. It is going to add only at this position. Okay. So if you want to, you can check the range also, right? That kind of program also I have explained already. Okay. So I think how you can able to add the particular element at a given position, it is very clear for you people, guys. Right? Can you please confirm? Do you have any doubts up to this, friends? Please confirm. Is it clear? Yes, everyone, please respond. Good evening, everyone. I think in the last video, we are talking about a circular single linked list, right? Yeah, very good evening. So circular single linked list. So in that, I explained very clearly how we can able to add the elements. Okay, how to represent this circular single linked list. So next and after that, how to add the, how to print the values. And even we have discussed how to add at the beginning. So how to add at the ending, even how to add at a specific position also, we have seen very clearly with example program in the last videos. Okay. Now in today's session, I want to talk about deletions, sir. Okay. I want to talk about deletion. Sir, suppose consider I have linked list like this. Okay. So consider I have linked list like this. So list dot add tail of. So I want to add 5. Okay. Next list dot add tail of. So I want to add 6. Like this, we have some elements are there. Since it is a circular linked list, so 1, 2, 3, 4. Next and after that 5. Next and after that 6. Like this we have. Let's execute up to this. So you can able to see we have 1, 2, 3, 4, 5, 6 are there. Now my requirement is I want to write a function to remove the element. Sir, which function we need to take? So void, okay, remove head. That means what? I need to remove the first element. How to write code for that? Okay, now observe carefully. In the remove head, suppose if your size is equal to 0, that means I can say my circular single linked list is empty, and return the value, return the control. Suppose if it is not empty and tail is equal to tail dot next. So means what? If you have only one element is there means, so that element next field is pointing to the same element, right? In such cases, what you need to do? You have to remove that entry. Else, otherwise what will happen? Otherwise what will happen? Your tail dot next, your tail tends to next field will become, so tail tends to next is there, right? It's a next field like this I'm taking. So after completion of this, anyway, you have to decrement the size by 1 unit. Okay. So I will explain with the help of a small diagram. Observe carefully. So consider I have one single, circular single linked list is there in this style. This is nothing but node 1, and the next node is nothing but this one. Okay. And the next node is nothing but I have like this, and the next node is nothing but I have like this. So its next field is pointing to the beginning, right? So which one will become tail? This node will become tail node. Now consider another case is what I have only one node is there. So its next field is pointing to the same. So this will become tail. Consider the data is 100. First case, if size is equal to 0, then single linked list is empty. If tail is equal to tail tends to next, my tail is tail tends to next, right? Then we are making this a tail to point to null, which says that empty list. Otherwise, that means this case. So tail is equal to tail tends to next. If it is the case, this is the thing. Otherwise, tail tends to next is there, right? Okay, which will become, so tail tends to next tends to next. That means tail tends to next is nothing but this one. Its next field is this one. So this one will become, so tail dot next. Okay, so now we are making this link to point to this one, so that this link is gone. This link is gone, and by default this node is deleted. Now this is nothing but the circular list what we have. Okay, this is nothing but how to delete the element from head node. Can you please confirm, is this remove head? Is it clear for you people? Is the first method, is it clear for you people, friends? Please confirm. Anyway, I'm not going to execute now. After that we will see. Okay, right, sir. Now see here, next one. So remove tail, remove tail. Now see what will happen. So if your size is equal to 0, okay, if your size is equal to 0, then what is the meaning? My circular linked list is empty. I am printing circular single linked list is empty, and immediately return. Sir, if this one is not satisfied, then if a tail is equal to tail dot next, means what? We have only one node is there. So in such cases, a tail will become null. Else, if it is not the case, here the cinema is going to be happen. Very, very important case we have to do. Okay. And after this, we need to make size minus max. Sir, what is this case? You need to take a temporary node. Okay. That temporary node is head, right? Here, how we are pointing head? Tail tends to next. Tail tends to next. Let us take a parallel example. Okay. So like this, we have one, and its next field is nothing but this one, and this next field is nothing but this one, and this next field will become this one. We need to remove this node, right? This is our target now. Now listen carefully. So this one will become tail. Now I am making so one temporary node which is pointing to tail tends to next. That means this will become which node now? Temporary node, right? Sir, next after this, so while temp tends to next is not equal to tail node, till to reach the tail node I am keep on doing, so temp is equal to temp dot next. Sir, is it a tail node? No. Then your temp will become this one. Is it a tail node? No. Then your temp will become this one. Sir, next node is a tail node? Yes. Then it will stop here. Come out from this while loop. Sir, after coming out from this while loop, your temp dot next field will become tail dot next field. Okay. Sir, my temp dot next field will become so tail dot next. That means this one. Okay, right. What is the next one? You have to change the tail also, right? Your tail will become temp. So that what will happen? This one will become tail. So means what? This reference is deleted. Anyway, this link also we have break, right? That's all. Okay. This is nothing but how you can able to do, sir. Okay. Sir, what is this functionality? This functionality is nothing but so circular linked list. Okay. So remove tail method. Okay. So I think it is very clear for you people, right? Any doubts, friends, up to this? Is it clear? Clear? Right. So you try to implement delete at a position. I will go with the deletion of element. Okay. Void. So delete element. So integer, I'm going to give the value. So with that value, we need to delete the element. But I need to check really whether first element got removed or not. What is that we have to call? So remove head. After removing head, if you print the output, what we are getting is nothing but sir head element. This first element will be gone. Let us run. Sir, one removed, right? Yes, perfect. Now I need to remove list data. So remove tail. I want to remove the last node. Anyway, first node already removed. So last node should be removed. Let me check. Yes, perfectly working. Okay. Now we have to write code for deleting the elements. Sir, as usual, if your size is equal to 0, then system.out.println of circular single linked list is empty, and then return. Sir, else what will happen? We are taking some special pointers like node. We need some temporary node. Okay. Otherwise, I will take previous node. Okay, which will become tail. So next I need to take a current node. I need to take current node, which will become tail tends to next. Okay. Next I need to maintain one more node called head, which will become tail tends to next. These many pointers are required. Okay. Now listen carefully. Why these many pointers I will explain. Okay. First I will execute I will write the instructions, then I will execute. Okay. So if so current node, okay, if a current node dot value is equal to the value which you are required to delete. Okay, if it is the case, again, if your current node, okay, if your current node is equal to so current node dot next, that means if you have only one node, then what we have to do, your tail will become null. Otherwise, what will happen? So your tail dot next will become, already we have seen this. So tail dot next to next, like this I am taking. And after completion of this, I think better to return from this. Sir, when this particular case is going to be happen, I need to demonstrate. Observe carefully. For example, consider I have only one node is there. Only one node is there. It is nothing but a 10. And this one will become tail node. So its next field is pointing to the same thing. Sir, current node dot value. So here we have assigned current is equal to tail tends to next. That means for this we have so many names are there. Previous is this one. So current is this one. head is also this one. Okay, now current node value 10, I want to delete 10 on. Okay, same, right? Then tail will become null, then tail will become null. This got deleted, so now we have empty list. Okay, for example, I have two nodes are there. This is nothing but a 9 and its next field is nothing but a 10. Like this we have. Okay, now its next field is pointing to this one, and this one will become what, sir? Tail node. And the data which I want to delete is a 10, and previous will become tail. So this one is another name for this is nothing but a previous, and current node will become tail tends to next. Your head is also tail tends to next. Is current node dot value is equal to value? Is it current node value is the same? No, current node value is not the same. That means we have to apply some other approach. Okay, so when it is going to be happen, suppose consider here we have 10 is there. Okay, so here we have 11 is there. Let us consider like that. So if current node is equal to current node value is equal to value. Yes, current node value is equal to value. Then is current node is equal to current node dot next. So this is the current node. Next field is also same. No. Okay. Then what will happen? Tail tends to next will become tail tends to next to next. So tail tends to next is this one. Okay, same node. So tail tends to next will become this one. So by default, this will be gone. Like this we have. Okay, I think these two cases are clear for you, right? Please confirm. Clear, friends? Is these two cases are clear? Right. Now, suppose if the current node dot value is not equal, then what will happen? Okay, so I think anyway we have used written, right? We are not required to write else, directly we can write the code. Okay, so if size is 0, it will return automatically. Otherwise, it is going to return like this. Now, sir, what is the next thing that we have to do? I need to take your previous will become current node. Okay, and your current node will become, so current node dot next. Okay, like this I'm pointing now. While your current node is not equal to head, your current node is not equal to head, and if a current node dot value is double equal to the value which you are searching, and one more if condition, if your current node is double equal to tail, then if current node is equal to tail, then your tail will become, so previous. Okay, so this is nothing but what we have if condition. Otherwise, so what we have to do? So here itself you can take one more instruction, like previous dot next field will become current node dot next. I will explain, don't worry. And we are returning. Suppose if current node value is not equal to this one, we have to interchange the, like previous will become current node. So your current node will become, so current node dot next. Okay, this is nothing but end of while loop, and we have to return at the last. That's all. Now see what will happen. I will execute with the help of a small code. Observe carefully, friends. Suppose consider I have a list like this. Like this we have, and these are nothing but the links what we have. And this one will become which node? Tail node, right? Now consider I want to delete the item called 4. Fourth node I want to delete. Now otherwise, to get a clear clarity, let us take 3. I want to delete the node called 3. Now see what will happen. Okay. Now, sir, previous, I think here we need to take some other notations, right? Have you observed? Previous will become tail. This one will become previous. Okay. Current node will become tail tends to next. This will become current node. So head will become tail tends to next, and this one will become head itself. Okay. Like this we have. Now observe carefully. So previous is equal to current. Previous is equal to current. So this is the previous, right? Okay. Now this one will become previous node. Observe carefully. Now current node will become current node tends to next. Now this will become current. Like this we are changing. Now while current node is not equal to head, is it a head? No. So till it is going to keep on searching till it reaches a head node, we are keep on continuing. Okay. If it reaches to head node means what? There is no data, simply return. So if it is not equal to head, is current node value is equal to value? No. Then is current node is equal to tail? Sir, if it is reached to tail, then what will happen? So tail will become previous. No, it is not a tail. Then so previous tends to next will become current node next. Sir, previous tends to next. Okay, will become current node next. So I think previous will become this one. Okay. So previous tends to next will become current node next field. Okay. Right. Now, so it will return. It will return. It will return means 1 second. No, sir. 1 second, sir. 1 second. Something is wrong. Second, please wait. Right. While current node, yeah. So while current node is not a previous will become current node, and current node is nothing but current node tends to next. I am getting confusion. So is it not equal to head, right? Yes. Then it will enter into if condition. Is current node value 2? Is it equal to this value? No. Then previous will become current node. Previous will become current node, and current node will become current node tends to next. Like this we have. Then since it is a while loop, again it will repeat. Is current node is not equal to head, right? Yes. Is current node value is equal to the value which you want to delete? Yes. Now if current node is equal to tail? No. Then sir, if it is not there, previous tends to next. Previous tends to next will become current node next. That means this link we are going to get. Right? Then return, come out from this. Anyway, these two links got break, right? That means this won't be there. Okay. So I think you people got very clear clarity about this. Please confirm. Do you have any doubts up to this, friends? Please confirm. Clear? Now. So let's clear all these things, and I need to check really whether it is working or not. What we have to do, let us remove all these things. So list dot remove, no, delete, right? So delete element, sir, something like 2. I want to delete the 2. Now what will happen? We have to get 1 3 4 5 6, right? Let us cross check. Yes, 2 got removed. Sir, let us delete 3. Is 3 got removed or not? Let us cross check. Yes, sir. And let us check for 4 also. Is it going to be removed or not? Yes, removed. Let us check 5 also. Is it removed or not? Perfect. Let us go for 6. Is it removed or not? Perfect. let us remove for one first element. Is it working? Perfect. Suppose if you want to delete 11, that element is not there, right? I think same list will be there. This is the way how you can able to implement single list. And anyway, last one, just I want to talk about Boolean search operation. So integer, I'm going to provide the value. It is very simple, no need to talk. So temp is equal to tail. Okay, temp is equal to tail. So for integer, I is equal to 0, I less than size, you can write like this also, I plus plus. Every time if temp dot value is equal to the value which you are searching, simply you can able to return true. So otherwise, if this condition is not satisfied, temp will become temp tends to next. Anyway, we are not required to maintain another thing. That's why I'm doing like this. And at last return false, since the result is not there. Now let us ask for search method. So system dot out dot println of, so list dot search of. Suppose I want to search for 1. What output we will get? It is going to return true because that element is existed. Suppose consider I want to search for 5. Is it there? Yes. Suppose I want to search for 54. Is it available? No. Okay, like this we have circular single linked list program is there, sir. Okay, I think how to work with circular single linked list, what applications I covered on this. So inserting an element at the beginning, inserting an element at the ending, inserting at a specific position, removing the element from the beginning, removing the element from end, deleting the element, and the search operation. Only I covered these 7, sir. Rest of the things you can try by yourself. Only thing is nothing but the basics I have provided. Okay, sir, clear up to this? Please confirm everyone. Is it clear?